Today we are going to see about auto transformer. Normally transformer is a static device which transforms the energy from one circuit to another circuit. And also transformer having two coils, primary coil and secondary coil. The working principle of transformer is same that of auto transformer, but here we have only one coil. The same coil acts as a primary as well as. So the primary and the secondary windings of two winding transformer have induced EMF in them due to the common mutual flux and hence in phase. The current drawn by these two windings are out of phase of 180 degree. This promoted use of part of primary as a secondary. This equivalent to the fusing the secondary turns into the primary turns. The fused section need to have cross-sectional area of conductor to carry the ampere. This through the led to the invention of auto transformer. The physical arrangement of auto transformer. The total number of turns between A and C are T1. At point B, connections are taken. The section AB has T2 turns as the volt per turn, which proportional to the flux in the machine is same that of whole winding. V1 is to V2 equal T1 is to T2. The simplifying analysis, the magnetizing current of a transformer is neglected. When the secondary windings delivers a load current of 12 ampere demagnetizing ampere turns I2 T2. This will be countered by the current flowing to the source through the T1 such a current of I1 ampere flows through the winding between B and C. The current in the winding between A and B is I2 minus I1. The cross section of wire to be selected for AB is proportional to the current assuming a constant current density for the whole winding. Thus some amount of material saving can be achieved. Compared to the two winding transformer, the magnetic circuit is assumed to be identical and hence there is no transformer expressed fraction of used two winding transformer. This means that the auto transformer requires the use of lesser quantity of copper given by the ratio of turns. The ratio there denotes saving in copper, so space for second winding need not be there. So the window space can be less for an auto transformer, giving some saving in the lamination weight also. The larger ratio of voltage, smaller in saving, so the T2 approach T1 saving becomes significant. Thus the auto transformer become ideally choice of closer ratio transformation. So the regulating voltage of transformers requirement that often arises a power application. The application may be used to supply a desired voltage to the load, to counter voltage drops due to the load, to counter the input supply voltage change on load. So this is the diagram for tap changing and buck boost arrangement. The voltage control performed by changing the turns ratio. This is done by the transformer portion of taps in the winding. The volts per turns available larger transformer is quite higher. Hence the change in even one LV side represents a large percentage of change in voltage. Also LV currents are normally too large to take the out of tapping from the winding. The LV winding being inner winding in a core type transformer add to difficult taking out the taps. Okay, thank you.